All right, so we're going to keep on going with chapter 1 today. So we're doing section 1.2. You can see on our schedule for the week over on the sideboard, we are doing 1.3 tomorrow. Then Thursday, we're going to slow it down and review a little bit. Friday, we are taking your first quiz. Quizzes in here are worth 50 points. So that's kind of your first big grade is on Friday. So hopefully you guys are good to go. Just a quick reminder, I do not allow phone calculators on quizzes. Your phones need to be away, out of sight during a quiz. So if you feel like you need a calculator Friday, I have like 3 of them I can lend you. It's probably a good idea to bring your own. Any questions? All right, so once again, just a quick review of what you should be writing. You always need the section number and then the title. The objective is just sort of to give you a preview of what you're going to learn about that day. So our objective is to use inductive reasoning to make conjectures. You can probably already tell there's going to be some vocabulary words today because there's some things up there I'm not quite sure we know what they mean. All right, so 2 vocabulary terms on the board. You need them both in your notes, so we'll give you a couple minutes. The first one is a conjecture. A conjecture is an unproven statement based on a pattern or observation. So that's the whole reason we did patterns first, so we could talk about observing things, noticing what's happening each time, and then moving forward, guessing what would come next. So we're going to use that skill. It's a conjecture just based on what we observe. And then that whole process is called inductive reasoning. It's looking for patterns and making observations about those patterns. So these are the steps we're going to follow today. These don't need to be in your notes. We're just going to stop and look at them, read through them. So what we're going to do today is follow these 3 stages of reasoning. We're going to first look for a pattern. That's what we practiced doing yesterday. So we're going to look at several examples. Using diagrams and tables, we're going to help to discover a pattern. I don't do a lot of diagrams and tables. I usually just make a list. I think it's easier just to see really quickly in a list. We're going to make a conjecture. A conjecture, remember, is just sort of a guess. You try to guess what's going on based on the pattern you observed. And then number 3, we're going to verify the conjecture. So we're going to double check to see if it works. If it works, we're good to go. Okay? So here is our first example. I'm actually going to only do part 1. So if you could write that down, leave the blank. I'll give you a couple minutes. And then we're going to see if we can observe a pattern, guess what's happening, and then check to see if we're right. All right, so we're going to add some little side notes here. The first one. What does this word mean? Yes. Sum is the answer to an addition problem. So when you see the word sum, not S-O-M-E, S-U-M, sum, that means we're adding, okay? And then here's another one you need to know. Odd. What are odd numbers? Give me an odd number. 1, 3, 5, and so on, okay? So you gotta use a little bit of your prior vocabulary knowledge first to sort of think of what types of numbers we're doing. So basically, we're going to take 2 odd numbers, we're going to add them together, we're going to see what happens. So, someone throw out an odd number. Any odd number, go. 9 and 7, I heard. 9 plus 7 is 16. You should be writing this in your notes. Give me another odd. 3 and 15 gives me 18. Okay? Let's do one more set. 11 plus 1 equals 12. We are trying to observe a pattern. What do you notice about all three sums? They are even. So my conjecture is that the sum of two odd numbers is even. Now, before I just move on, I want to sort of pause and try to think of a time when that's not true. Can you think just quickly in your head of any two odd numbers that add to give you something that's not even? Add two, like just in your head. Go through the odd numbers, like 3 plus 5, that's 8. 5 plus 7, 12. 7 plus, just real quick. Can you think of a time where you add two odd numbers and you get something that's not even? I cannot, off the top of my head, think of a time when that would happen. So I'm going to go ahead and say I am confident this is my answer. All right, so similar idea, but now we're working with the word product. So off to the side, can anyone tell me what that means? Product. Sum is add. Product is multiply. So make that little note because you'll have to know that for your homework tonight. So product of, and then again, odd numbers. We talked about those like 1 and 3 and 5 and 7. So the product of any two odd numbers is, so give me some odds. 1 times 3 equals 3. That's one example. 11 times what? I'm going to veto that because I don't know 11 times 13 in my head. 5, I know that one in my head. That's 55. We can do 13. Let's just do a little number. 13 times 3, 39. That's beautiful handwriting right there. All right, so what do you notice about all of our answers? They're odd. So my conjecture is that the product of any two odds is going to give me an odd. Now, can I think of a time when that is not true? All right, can you think of a time when this is not true? I can't think of a time. Every odd number times another odd number. The ones are really easy to check, like 1 and 5 and 1 and 7 and 1 and 9. They're all going to be odd, okay? What are your questions? All right, so you need this guy in your notes too. So you can already tell tomorrow the yellow highlighter is going to get a good workout. And you don't need what's in the parentheses, just the basic definition is fine for me. So we are talking about counterexamples. A counterexample is an example that shows that a conjecture is false. So I actually, without using the word counterexample, asked you to try to think of one on the last two examples we did when I was like, can you think of a time this doesn't work? That would be a counterexample. Basically, you're just trying to prove that they're wrong. Now, the good news is that teenagers are naturally amazing at this skill, okay? I'm not sure what it is. I feel like between the ages of like 13 and 22, it just comes automatically. You want to argue with everything that you hear. So you have my permission today to argue, all right? So I'm going to give you a statement. It is not going to be true. Your job is to be like, nuh-uh, and then give me a counterexample. Sounds awesome, doesn't it? We will do both of them, but I will only make you write B. So everyone just write B. You don't even need to write the directions. You'll know what the directions are once you see it.
Done. I just wrote B.
Sounds good. Thank you. So we're going to do A together. Then we'll do B, and you can write the answer for B. A is just sort of a watch. Get used to it. Then we'll move on to B, and you can have it in your notes. I try not to make you write a bunch of notes just for the sake of writing a bunch of notes. Okay, sum. So I will be correct, adding. All right, the sum of two numbers is always greater than the larger of the two numbers. So all I have to do is show a time when this isn't going to happen. So somebody give me a number. 39. I want it to be a big number. Can you think of a number we can add to 39 and get a number that's not bigger than 39? -2. Perfect. This is my counterexample. I just showed a time when I had the sum of two numbers and my answer was not greater than the larger number. You don't have to give me big long sentence. You don't have to describe it. You don't have to tell me how you came up with it. Boom, counterexample, you're done. Now, B is the one I want in your notes. If the product, so we will be multiplying, if the product of two numbers is even, then the numbers must be even. So we're trying to come up with a problem where we're multiplying, and my answer is even, but the numbers in the problem are not even. A counterexample. So what's the opposite of being even? Being odd. Somebody give me an odd number.
3.
Okay, 3. Can I multiply 3 by something and get an answer that's even?
Yes, you can. 3
What?
times 2 equals 6.
There you go. That is a counterexample. I just showed that it's possible to get a product that's even without both of the numbers in the problem being even. That's it.
Even and odds are like, I'm really good at
That's your jam?
it. No, that's not music. That's
Okay. Sounds
that's like
good.
maybe worse than just beers with
Got it. All right, so these take a little bit to get used to. That's why, on your homework, we'll go through what you've come up with tomorrow when you get to class. We'll see if your counterexamples work. The cool thing about counterexamples is that we could all have different answers and we could all be right. Yeah, I like it.
How you gonna rate on it?
That's why you're great now. All right, let's do this one together. If the sum of two numbers is positive, and you don't need to write it in your notes, we'll just do it out loud. The sum of two, if the sum of two numbers is positive, then both of those numbers are positive. We could use one we already used, actually. Did we add two numbers with one of them not being positive on the last slide? Do you remember that? I believe it was 39 plus -2, and we ended up with 37. That actually works here too. If the sum of two numbers is positive, so here's my sum, the sum is positive, the numbers must be positive. Well, no they don't. I just showed a time when one of them was negative. That's a counterexample. Just proving them wrong. Yes.
Is it a way to do it without having a negative number?
The sum of two. You could use a 0 because 0 is not considered positive or negative. So if you wanted, if you wanted to do like 4 plus 0 equals 4, I'm still getting a positive answer for my sum, but the one is, or the 0 is not considered positive. Good times. All right. Now we're getting into a little geometry. all shapes with four sides. All shapes with four sides.
The same.
That doesn't make sense. All shapes with four sides, like that are the same length.
No, rectangles.
The square.
All shapes with four sides. So if the four sides are all the same length, do I automatically have a square?
No.
You could make a diamond, a rectangle.
Where'd it go? So I think you're on the right track. You said a diamond. So like they could all be the same length,
Or a
but they don't
rectangle.
have right angles.
Yes.
There you go. That's a counterexample. These are all the same length. That's how we show things are the same length in geometry, by the way. We just mark them in the same way. So they can all be the same length and not make a square. Now, a rectangle is not going to work because in a rectangle, they're not all the same. These two are the same. These two are the same. So yeah, the key here is to draw all four sides the same and just sort of stretch it out in one direction or the other so that it's not a square.
And we'll get to it later,
Kinda
but that's
fun.
geometric. It's called a rhombus.
A rhombus, yes. All right, you need the answer for this guy in your notes. I will help you write it in a complete sentence. What did we learn today? So I will start with today. We learned, or I learned. What did we learn about today? Are you doing the summary with us?
What?
The summary? We're doing our summary now. So what did we learn about today? Today I learned
About eyes.
Conjectures.
counterexample. Did you say counterexamples? Okay, good. Awesome. Today I learned about conjectures. And counterexamples. I don't know why I'm writing so massively large. Okay, I cannot fit anything on there. Okay, so that's the part I need in your notes. Hopefully it's not as giant and spread out as mine. But today we learned about perfect conjectures and counterexamples. And then the other two we'll just do out loud. What questions do you guys still have about this?
Why do we have to do this stuff in the first place?
I'm going to go ahead and decline the answer to that question. Does anyone have any other questions? Okay, and then real quick, let's just brainstorm. What would this look like on a test? Difficult. You know what I love to do on the test for these?
Looking at fire and make my eyes burn.
I like to do ones that aren't necessarily math. So like, everyone that goes to Belleville West is a freshman. And you'd have to come up with a counterexample. What would a counterexample to that statement be? There are sophomores. There are juniors. There are seniors. Okay? So you can do counterexamples even with things that aren't math related. And that's what I like to do on the test. Just like throw a curveball in there, see if you really get it. So anyway, that's kind of what these would look like. And then those beginning conjectures, they'll look just like they did in the notes, where you're finding, what is the sum of two odd numbers is blank. So sort of keep your eye on those. Anything else you guys think we need to talk about, or we're going to pass out your homework?